Okay, so today we are going to start off with an equation as we find out what pH is, then we're going to put it into practice, and then we're going to look at how to measure it. And as always, download your own copy of this PDF so you can be making your own notes as you go through. The link is in the description. Okay, so on to pH. So here is our equation for pH. So all pH is just a measure of the hydrogen ion concentration. So if you want to know what the pH is, and you know the hydrogen ion concentration, you just do the negative log multiplied by the hydrogen ion concentration, and then you have the pH. You can also go the other way by using the inverse log function. So if you have the pH and want to know the hydrogen ion concentration, you can use this equation. So the reason we are using a log scale is because it makes the numbers a lot easier to understand as we look at some data in a second. And then finally, that negative value means that the smaller the number is, the higher the concentration of hydrogen ions is. So that's really the key thing, is that hydrogen ion concentration is what pH is. There's nothing else to it. Okay, so let's have a look at our data. So we can see pH is increasing as we're going down, and then the hydrogen ion concentration is decreasing. So as we change pH by 1, we can see that the hydrogen ion concentration is changing by a factor of 10. And this is due to the fact that we are using a log scale. And then hopefully you can see that it's a lot easier to use these numbers compared to these very, very small numbers. Again, this is why the log scale is used. Okay, we can also plot pH against hydrogen ion concentration. So we can see that for most of the pH range, there's not much change. And yet this is really important to bear in mind when we look at titration curves in later in the topic. But now on to some practice questions. So let's have a look at our first question. So calculate the pH of a 0.05 moles per decimeter solution of hydrochloric acid. So so hydrochloric acid fully dissociates. So if this has a concentration of 0.05, then we're going to have a hydrogen ion concentration of 0.05. So now we know the hydrogen ion concentration. We're just putting it into our equation, putting the numbers into our calculator, pressing equals, and then we're getting a pH of 1.3. Okay. Now on to the reverse. So in this case, we've got a nitric acid solution and it has a pH of 3.6. But what is the hydrogen ion concentration? So we're using the inverse log function. So 10 to the negative pH, so 10 to the negative 3.1, and then this is giving us a concentration of 1.6 times 10 to the minus 4 moles per decimeter cubed. All very straightforward, I hope. Okay. Now onto our final thing of how to measure pH. So we've looked at calculations, and these calculations will get trickier as we move through the topic, but now how to measure it in real life. So there are two ways, and the first way is qualitatively. So this is using colors, or you can do it quantitatively using a pH probe. So both have their advantages and disadvantages. So qualitatively, using universal indicator or litmus paper. It's very, very quick and very easy to find out what the pH is. So this is universal indicator paper. It also comes in solution form. And then you dip the paper in, and then based on what color it goes, you can figure out roughly what the pH is. Litmus paper is even more basic. It just tells you if something is an acid or an alkali. But again, that's very useful information to have. But it's not very accurate. So if you want to have something that has some numbers, then you will need to use a pH probe. And this is what ChatGPT thinks a pH probe looks like. But it's very, very simple. Even though it might not look exactly like this, you've basically just got something that either has a readout on it and it gives you the number straight away, or you can plug it into a computer and that will give you the number. You can also use it to log changes in pH over time. So the pH probe can be good, but they take a bit of time to set up. Not a huge amount of time, but they do take a bit of time to set up because they need calibrating, because they don't always give the most accurate results. So even after calibrating, they may not be 100% accurate, yeah, again, this is just due to how little change in the concentration of the hydrogen ion that there is that causes a big change in pH, as we saw earlier from this graph. But yeah, so measuring pH and doing things like that are great for kind of doing an individual investigation for doing your IA. So if you are looking at pH with your IA, make sure you are happy with using a pH probe. So that is everything from me, and yeah, if you want some IA ideas with the pH probe or extra chemistry help, then please do check out my website. The link is in the description where you can find out about tutoring. But yeah, please do remember to like and subscribe, as this will mean so much to me. And yeah, if you do that, then you'll get a notification when the next chemistry video is ready. All right, thank you again for watching, and yeah, catch you in the next one. Ciao.